And welcome to the end of our Chapter 1, Previewing Calculus. So today what we're going to do is we're going to do a review. The review is going to be on computing linear equations from tables, computing quadratic equations from tables as well, that's both using graphing calculators, be able to sketch some trig functions with shifts, find some inverse functions, reduce any functions that had exponents inside them, expand any natural logarithmic functions, and contract any natural logarithmic functions. And we're all going to use the rules you guys have been learning from 1.4, 1.5, and 1.6. So, first thing, how do you find a linear equation using a graphing calculator? Quick review. To do this, you first input your points. You have your L1, which is your X, your L2, which is your Y. You put them, you press stat edit. L1 goes in the first column, L2 goes in the second column, your X and your Y's. Then you press the stat button and the calc button, and then the lin reg button, and that gives you your least square regression line. To find the regression coefficient, hit the varies button, variables. Number 5, statistics, EQ, and number 7, that gives you a little r, which is your regression coefficient. If you want to square it, you can, and that will give you your percentage. Okay, and then if you want to graph, you can graph it, but we don't have to worry about that right now. So, to do a quadratic equation, all right, quadratic, use, upside down use. You do the same thing with inputting the points into L1, L2. To find the least square regression line, though, you hit stat calc. Now you hit number 5, quad reg. Only difference there. Regression coefficient, var stat, EQ. Number 9, capital R squared. Okay. Once again, to find the percentages, you square, multiply by 100. Got it? So let's look. In this question, an experiment. So hopefully you did all these questions. We're going to go check them. Student measures the speed, ms, of a object thrown off a cliff in t seconds after it was released. So, t, my L1, my x, L2 is s. Dependent, dependent, independent. So, s depends on t. Well, then counts over here. Use our calculator. First thing when you get a calculator, you always want to clear the memory. Hit the second, the mem button. You go down to reset and reset all rams. What that will do is that will reset your calculator back to when it was originally purchased, pretty much, and gives you good. Now, you hit stat edit, and what you do here is you're going to type in all your L1s, 2, 4, 6, 8, 10. All right, in the first column. Go to the next column, 46, 94, 139, 180, and 240. All right, so you type in everything in your two columns. This is the key. Now, to solve your least square regression line, what you're going to do is you're going to hit the stat button. All right, you're going to go over to calc, which is over 1. You're going to go down to number 4, which is lin reg. You type calculate, and you get A is 23.7, B is negative 2.4, so it's S equals, Y equals 23.7 T, which is your X, minus 2.4. 23.7 is your slope, negative 2.7 is your Y-intercept. Next thing, the regression coefficient. You hit the varies button. All right, you go down to number 5, stats. You go over to EQ, and then you go down to number 7. All right, you get 0.9980. That is your regression coefficient. If you want to find the percentage, you can square this number and then multiply it by 100. And that's all there is to it. Now, what would the speed be when the time is 6.8 seconds? So, we're going to use this equation. So what would the speed be, s, when the time is 6.8 seconds? You take 6.8, and that is going to be your t. And all you do is you take this equation, and you're going to plug t in for, 6.8 in for t. So 23.7 times 6.8t minus 2.4. All right, 158.76 meters per second. And that's it. Boom. See what that is? Number 2, students in a lab measured the bending pliability B of a metal A inches thick and X inches high and 30 inches long. This is X, this is the inches high, and B represents here means how pliable it is, how bendable something is, okay? Quadratic regression line. So your L1 is your X, your L2 is your B. So once again, we're going to use our calculator, and you're going to go to, stat edit, and then you get to, these are my L1s, these are my L2s. I type them all in. I am going to then go to stat, calc, quad reg. Stat, over to calc, down to quadratic. Number 5, not number 4. Hit enter, and you get A is 127.09 x squared. B, not this B, not the pliability B, just the B that goes next to the x. Negative 105.70, and then you got 58.96. All right, notice I just went to 2 decimal places in each thing to try to keep it equal. Regression coefficient. Varies. Number 5. EQ, all the way down to number 9, which is big R squared, and you get 0.9999. All right, rounded the 8 up to a 9 because the 8 behind it is higher than 0. All right, that is obviously 99.8%. All right, now next one. Use the model to approximate the bending pliability when the height is 4 inches. I'll just stay over here. So when x is 4, where do we plug this 4 into? Plug the 4 into the x. So, 127.09 times 4 squared minus 105.7 times 4 plus 58.96. You have to plug it in for both x's. And now you just type in your calculator, and as an answer you get 1,669.9 units. All right, they didn't give you units up here for how pliable something is, so you don't put a unit number down there. That's it. All right, there's your calculator work. Trig functions. I'm just gonna stay over here. You got sine, cosine, tangent. The inverse of the 3, cos you can't see, you can't cotangent. You also have to know a period, plus or minus pi is the base period. All right, that's the value it goes before repeating. Amplitude, plus or minus a. Okay. So that is the highest and the lowest point on the graph. You can obviously shift these if you want, but this is the initial one. And then your frequency, how often the graph repeats. So if I'm giving you a start and a stop point, how often the graph repeats between those 2 points. Way you find these answers real quick. Formula typically is y equals a sine bx. Okay, if that is true, a base formula with no horizontal or vertical shifts right there. The A is your amplitude, that's your highest and your lowest points. The B has to deal with your period. So you take 2 pi and divide it by B, and that's how far your graph goes before it repeats. All right? If you're going to have a vertical shift, you would add or subtract a number after your trig function. So it would be this stuff plus or minus and then a number, and that would be how much it goes up or down. If it's positive, you rise up. If you're negative, you rise down. Horizontal, if you plus or minus something inside the actual function of the trig thing. So if I actually did b x plus or minus something here, whatever that is, divided by whatever's next to this x variable, that would be your shift. If it's positive, you move to the left. If it's negative, you move to the right. Got it? Good. Hopefully. Now let's go through some problems. Let me pop that over here. Ooh, popped out of me. Problem number 3. First thing, you do the problems yet? Don't just copy me. Do the problems first. Good. All right. A, right there. 1/3. This is 1, 1, 2. 1/3 would be up 1/3, down 1/3. So that's my initial amplitude. All right. Period. Period equals 2 pi over the absolute value of b. B is whatever next to the x. B is 1/2. 2 pi divided by 1/2. So when you divide something by a fraction, you multiply by its reciprocal. So 2 pi times 2 over 1 is 4 pi. So that means this whole graph, which is going to be my cosine graph, has to go from 0 to 4 pi. All right? And once again, if you forgot the cosine graph, it starts at the amplitude, ends at the amplitude. So I'm going to start at 1/3, right? I'm going to go all the way and I'm going to finish at 1/3. Directly between the two, I got a negative 1/3, and then it crosses the 0 between these two and between these two. Got it? You're pretty much going in quarters. Now, after we do this, we do the same thing on the left-hand side. So since we went to 4 pi here, we go to negative 4 pi, we start over here, and we do the same thing, down, down, up, up, and we have our initial graph. Now, because of this pi, there's going to be a shift involved. You can graph the shift right away if you want. I like to graph the original one and then do my vertical and horizontal shifts, just me personally. Now, that's why I put the dash here, because it's not my completed graph. So a horizontal shift, we're going to use that right there, that's C. So it's C divided by B. So it's pi divided by 1/2. Once again, when you divide by a fraction, you multiply by a reciprocal. Pi times 2 is 2 pi. So because this is positive, it means you're shifting to the left 2 pi. So each one of these points is going to go over 2 pi to the left. All right, so this goes over 2 pi to the left. This slides over 2 pi to the left. All right, this slides over 2 pi to the left. This slides over 2 pi to the left. You get it? These guys slide over. So my graph looks like that. Good. That's it. Maybe put some arrows there, but I didn't. All right, ready for the next one? 4. What's my amplitude? 2. 2, negative 2. Period. 2 pi divided by 2. Pi. All right, so from 0 to pi, I have to draw a sine. So sine starts at 0, ends at 0. Starts at 0, ends at 0, has a 0 in the middle. Right? And you go up, down, down, up. Amplitude 0, negative amplitude 0. And if I start at negative pi, I do the same thing. If I continue, up, down, down, up. So you can just pretty much fill in the rest of your dots. Got it? Got it, got it? Good. All right, vertical shift. Which way? 1 up because it's positive. So all these little guys are going to go up 1. Horizontal shift, there's nothing inside the function, so there is none. So all I do is I take this graph right here, and I'm going to take each one of those points and slide them up 1. All right, I'm going to take this point, slide up 1, up 1, up 1, up 1. They're all up 1. And then that's my final answer. All right, that's it. Doesn't seem too terrible, right? That is moving trig functions. I don't know if I'm in your way. All right. Now next we're going to go to finding inverse functions. So finding an inverse function. First step, replace the f of x with a y. Y equals 1/3 x minus 17. Okay? Switch that with an f of x. Oops, sorry, f of x became y. And then step 2, switch the x and the y. X goes to y, y goes to x. Step 3, solve for y. So I have to isolate y here by itself. So I do the opposite of PEM does, parentheses, exponents, multiply, divide, addition, subtraction. So to balance the equation, I have to add 17 to both sides. X plus 17 equals 1/3 y. To isolate y, I have to multiply both sides by 3. Take the 3, distribute it in. 3x minus times x plus 17. 1/3 of 3 is 1, so that leaves you with the y, because the 3's cancel out. And you get f negative 1 equals 3x plus 51. Because 3 times 17, obviously, is 51. You okay? Next one, ready? Replace the f of x with the y. Y equals 6x to the 4th minus 13. Flip the 2. X equals 6y to the 4th minus 13. Add 13 to both sides. X plus 13 equals 6y to the 4th. Divide both sides by 6. So now you get y to the 4th equals x plus 13 over 6. Do you remember how to get rid of that y to the 4th? To get rid of an exponent, you do the radical of that exponent. So the cubed root 4 of both sides. So f negative 1x equals the 4th root of x plus 13 divided by 6. Because the 4th root of y to the 4th is y, and then you just replace it back to this guy. All right, excellent. 2 more inverses. What is a trig inverse? We did this with the do now. So replace the x and the y. I didn't have space, so I just do it right away. You get y equals 1/3 tan 2x plus 1, so x equals 1/3 tan 2y plus 1. All right, now you have to isolate y by itself, so the first thing you do is you multiply both sides by 3. 1/3 times 3, that cancels out. You're left with 3x equals tan 2y plus 1. Now to get rid of tangent, you have to do the inverse tangent of both sides. This goes back to geometry. So tan negative 1 of tangent just becomes 1. So you have tan negative 1, the inverse of tangent of 3x equals tan negative 1 tan. These actually cancel out. 2y plus 1. So you're left with a 2y plus 1. So the inverse tangent of 3x equals 2y plus 1. Now you just solve it. Just solve for y easily. Subtract 1 from both sides. Inverse tan 3x minus 1 equals 2y. And finally divide both sides by 2. So you get y equals tan negative 1 3x minus 1 divided by 2. Inverse of x equals inverse of tan 3x minus 1 by quantity divided by 2. All right. Not too shabby, right? That wasn't too terrible. Alright, let's replace the x and the y. Boop. Subtract 10 from both sides. Now, this is the tricky part. You have to multiply both sides by 6y minus 3. Cancels that out. Because you can't have it in the denominator. You need it in the numerator. Don't distribute this, though. So just cancel them out. Leave us 6y minus 3 times x minus 10 equals 18. Good. You divide both sides now by x minus 10. So you're kind of doing like a cross multiplication thing here. That cancels out, leaving you with 18 over x minus 10, 6y minus 3. Now you solve for y easily. Add 3 to both sides. 6y equals 18 divided by x minus 10 plus 3. Divide both sides by 6. Now, when I do 18 divided by 6, so this is technically 1/6 times this. 18 divided by 6 is 3, so I'm left with 3 up top. 3 divided by 6, oh, here we go. 18 over 6, right? Because I distribute the 6. And then 3 over 6, I distribute the 1/6. 18 over 6 equals 3 over x minus 10 plus 3 over 6 is 1/2. That's your final answer. Sorry, I was jumping ahead of myself. Tend to do that just a couple times. Ready for the next one? You are? Awesome. See, this is easy. So let's on the test. Reducing exponents. Ooh-wee. All the way back to 8th grade, probably. Any exponent to the 0 power is 1. When you multiply things with the same base, add their exponents together. When you raise an exponent to a power, you multiply the two. If you have two different functions and they're both raised to a power, you could raise each one of those individual functions to that power. When you divide exponents that have the same bases, you subtract. When you raise a fraction to a power, you raise the numerator and denominator both to that power. When you raise a fraction to a negative power, it's 1 divided by that. Got it? So first thing, multiply the two numbers. Negative 5 times negative 12 is 60. 7 plus 5 is 12. This is easy. We're going to have to reduce some stuff here. So match up the things that you're going to reduce. 12 over 18, what number goes into both of those? 6. So 12 divided by 6 is 2. 18 divided by 6 is 3. 3 minus 1 and 10 minus 13. So that reduces to 2/3, x squared, y to the negative 3. Now another way you could do this is, you go, okay, I have 2 more x's on top, I have 3 more y's on bottom, and leave it like this. So you can either do 2x squared over 3y cubed, or you can do 2/3 x squared, y to the negative 3. Either one is a correct answer. Right. 14, first thing you have to do is you have to raise both of these to a power. Do not forget to raise the 2 to the power. 2 to the 4th is not 8, it's 2 times 2 times 2 times 2, which is 16. 3 times 4 is 12, 4x to the negative 3. 6 times 4, 12 minus 3. Remember, you add exponents when you multiply them together. You get 64x to the 9th. Right? So easy. Now, when you raise something, first off, when you raise something to the negative 2, we're going to go work on this inside stuff first. So first thing, whoa, where did I get all that stuff from? 14 over 45, divide by 15, you get 1, divide by 15, you get 3. X to the 0 equals 1. X to the 3 times 5, because you're raising a power to a power, and then you have 17 minus 11 right there. So you got 1/3, x to the 15, y to the 6th, the negative 2. Got it? Not too bad. If you raise something to a negative power, you multiply. So this becomes x to the negative 30, y to the negative 12, 3 to the negative 2. Okay? The negative powers mean they go to the opposite side of the fraction bar. So the x to the 30 goes to the bottom, y to the 12 goes to the top. 3 squared is 9, but that moves to the top. So you just move them all, and you make the 3 squared a number. That's it. Almost done. If you have questions, email, ask. All right, expand, contract. Properties of logarithms. Ln, I call it ln. I know it's bad to do, but whatever. When you do multiplying, you split them up and add them. Division, split them up and divide them. Raise to a power, you bring the power to the front. So let's break up this guy nice and easy. First thing, like I said in the couple lessons ago, you are going, or was it last lesson? I forget, they all merge together. you're going to split up the top and bottom first. Top becomes plus and the bottom becomes minus. So it's ln natural log, can't even say it right, 7x cubed minus natural log of 8 subtracted from x all to the 4th power. These two are split up as 7 to the x, so I can make them both pluses. This stays the same because it's in a parenthesis. Now I drag forward my exponents. There is no exponent here, so that stays. The 3 comes forward, and the 4 comes forward. And the last step is, there is no last step. That's my answer. Do you have to write this twice? Of course not. But I like this nice little cool magenta color. Reminds me of the Redskins, my favorite football team. Ooh, that's going to upset a bunch of you probably. Especially if you're a Giant fan. Ugh. Or an Eagle fan, even worse. All right, anyway. 14. Did you do it? Good. Plus, minus. Now, because this is even though these are two functions, because they're subtracted, you don't split these up, so there's no need to split it. All you have to do is one more step, just drag that 1/5 forward, and you're actually done, and that's it. All right? You don't break up these two. You can't distribute the natural log into these two. Because this function is, the whole thing is the function, it just stays that function. Okay. What do you do after you expand? Yes, you contract. All right, let's contract one. 5 ln x minus 3 ln x plus 2 ln x minus 11 plus ln 12. So, take all the pluses. Plus, 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 numerator, negative, denominator. All right, so all the numerator pluses are on the top, numerators on the bottom. Now, to the 5th power, squared, cubed. Okay, so you deal with your exponents next. And now, because these are all pluses, you can just multiply them together. Put your numerator first, 12, x to the 5th, x minus 11 squared. All right, all over x to the 3rd. Now, what happens here is you have an x to the 5th on top and x to the 3rd on bottom. Remember your reduction? I can take x cubed and x cubed away. 5 minus 3 is left with an x squared up top. So my final answer is x squared, x minus 11 squared, times 12 over 1. You don't want to divide things by 1 though. So like I said previously, put the 12 first, x squared, x minus 11 squared. You could reorganize them whenever you want, but always you want to put your coefficient first, followed by descending order of variables. Got it? Let's try this one. You got it already? Awesome. Only one more slide after this. Plus, top, bottom, bottom, top, top. 1/5. Oh, we already did that. So the 1/5 comes to the top. Squared. All right, so we already did that stuff. That, multiply them all. 3 squared is 9. You can actually do that. Okay, 9 times, so now this step, 9 times a half is 9 over 2. Divided by 9, so the 9s actually cancel out. And this 2 goes to the bottom. So when you have 1/2 x to the 1/5, or x plus 21, you actually take this 2, because you don't want a fraction over fraction, and move it to the bottom. So it's x to the 1/5 times 2x plus 2 times 21 is 42. Right. Or if you want to just do 2 times x plus 21 in parentheses. All right, let's move on. Last 2 problems. Yes, there's only 18. There should be 20, but it is what it is. Solve the functions. This was a quick little end of our thing. Maybe I should give you some more problems with these if I have more time. All right, so to get rid of the e, you have to multiply it by a ln. So, natural log 17 equals, now ln e to the x squared plus 5. Cancel those out. Left with x squared plus 5. Subtract 5 from both sides. Square root both sides. Now, in your calculator, you hit second x squared, open parentheses, ln button, 17 minus 5, close parentheses. Boom. And then it gives you an answer. Ooh, what's that mean? What happens when you have a radical negative? Remember I said we're not dealing with i's in this class. That's when you get to the higher level calcs. Doesn't exist. It just doesn't exist. Yes, you can get that as an answer. If this was a regular number, you get an answer. All right, so let's see here. First thing, we divide both sides by 3. Why? I got ln by itself. Raise both sides to the e. E to the all of this equals e to this. E and the ln cancel out, leaving with 5x plus 3 squared equals e to the 100 over 3. Now, what are we trying to solve for? We're trying to solve for x here, so we have to square root both sides. We have to subtract 3 from both sides, and then we divide both sides by 5. So your answer is, open parentheses, second x squared, e to the 100, e up arrow, open parentheses, 100 divided by 3, close parentheses, minus 3, close parentheses, divided by 5. I think that will work. And you should get 3,461,556. I hope my calculator work was correct for you. And guess what? That's it. All done. So this is what you're testing me on. As you can see, it's a fairly simple one. This took about 28 minutes to go over. So it probably wouldn't take you that much longer to do on your own. Being that you get 55 minutes for a test, you should have plenty of time. Right? If there's any questions, once again, email me. I will help you out. So until next time, glad I can help you. Can't wait for chapter 2 and to start calculus next week.